All right, so today we're going to take a look at points of inflection. So points of inflection pretty much goes hand in hand with concavity. So what we're going to do is, in order to find a point of inflection, we need to find out when the double derivative, so f double prime of x is equal to 0, or when f double prime of x is undefined. Finding those critical points of the second derivative. So once we find that, the second thing we need to do is find the point on the graph where our concavity changes from positive to negative, right? Concave up to concave down. Now, if we don't see that change in concavity, right, if the graph does not go concave up to concave down, it's not considered a point of inflection. But if it does, we have a point of inflection. So we're going to do the same thing we did the other day with concavity. We're going to find the double derivative, set it equal to 0, and then plot those points on the number line to take a look at what's going on around it, right? Whether we're changing signs or not. So to take a quick look at an example, and I have the graph of the example down here for you guys as well too. We'll talk about that at the end. We wanted to discuss the concavity of the graph of f of x equals x to the fourth plus x cubed minus 3x squared plus 1. And we want to find its points of inflection. Sometimes it will have 1 point, 0 points, or multiple points of inflection. So in this case, we want to first start by finding the first derivative. So we're going to find f prime of x, which in this case is 4x cubed plus 3x squared minus 6x. And we're still talking about concavity and points of inflection, so we want to go one more derivative. So we got to find the double derivative. So we'll take one more, and we end up with 12x squared plus 6x minus 6. All right, so our next step, we need to find the critical points for that second derivative. So we're going to set this equal to 0. So 0 equals 12x squared plus 6x minus 6. And then you guys will go ahead and solve from here. So one way of solving this is we could factor out a 6. And we'll end up with 2x squared plus x minus 1. And then we could do some factoring here. You guys would want to do a little rainbow factoring. So we have 0 equals, I'm just going to jump straight to the full factors, which is going to be 2x minus 1 times x plus 1. So we end up with two critical points. We end up with a 1 for the second derivative at x equals 1/2 and 1 at x equals -1. So the next thing we want to do here is we want to take these points and we want to put them on the number line. So we're going to put that 1/2. We'll put the 0 here. We want 1/2. And we're also going to test -1. We're going to put -1 as our other critical point. Now we're going to have to do a couple test cases. I'm going to test a 0. 0 is always a nice easy one to test. We'll test a number to the right. Let's test +1, and a number to the left. Let's test -2. So using the table on my calculator, I'm going to find that the double prime of -2, my first test point here, is equal to 30. That's a positive value. So we know that at this point, the graph is concave up. Then we'll test 0. When we test f double prime at 0, f double prime of 0, we end up with -6. And again, just getting this from the table, you're putting that double derivative, so 12x plus 6x minus 6 into your y equals screen, and then just taking a look at the table from there. Since that's a negative, we know that this is concave down. And let's test that last one. We're going to test f double prime at 1. And again, just looking at the table, I end up with a 12. So we know that that changes concavity. Again, we go back to positive and we're concave up. Remember, concave up looks like a cup. Concave down looks like a frown. All right, so what we have here is our points of inflection. Now we know that there is a point of inflection when x is equal to each of these critical points. We know when x is equal to 1/2 and when x is equal to -1. Now, in order to find out what those points of inflection actually are, what we need to do is we need to go put it back into our original function. Right, so we're going to go back up here, and we're going to take that 1/2. We're going to find f at 1/2 which when we substitute that in, you guys will end up with 7/16, 7/16. And we also want to find f at -1, which is -2 when you substitute it in. So what that brings us, and you guys could see on the graph here, is we have these 2 points that have been highlighted here. All right, we have the -1, -2, and the 1/2, 7/16. Those are points of inflection. One way to think of what a point of inflection is when the graph flexes from changing concavity. So you see we have concave, we're concave up, and then the graph is starting to flex, and it's starting to become concave down, and then it starts to flex again, and it changes concavity to concave up. So those points of inflection are when we change concavity, when the graph is starting to change curvature. All right, so when is the graph flexing? Take a look at a couple examples.